Thank you so much, Manushil sir. So as already covered, my project called Diagnosity explores the computational pathology as a real-world use case for composable agentic infrastructure. So now the reason we chose pathology is because of the first that we have in our at our disposal a chain of laboratories in India that have been in existence for the past 30 years and who that have been diagnosing cases and spread out across about 5 to 6 states in India, and also because pathology is a particularly useful domain since it combines large scale artifacts and audit requirements, recovery constraints, and it's a high stake decision environment. So our thesis is very straightforward. We believe that as AI systems become increasingly agentic, infrastructure requirements would expand beyond model inference and centralized coordination. So just for those of you who do not understand what histopathology particularly is, it's a branch of medicine where diseases are diagnosed by examining tissue under a microscope. For example, cancer, tumors, inflammatory diseases. These depend on biopsies and surgeries that are collected of tissues. Now these tissues are processed, sliced into very thin sections. They're stained and then interpreted by pathologists. These slides typically, when digitized, contain gigabyte scale information. So the workflows in pathology, they generate multiple intermediate artifacts. They have evidence chains. They've got annotations, diagnostic states, and review layers. It becomes quite interesting as a problem statement. Sorry, I'm unable to switch my, Right. So one important thing to understand here is that the pathology diagnosis is not a single step sort of process. It's a sort of a. I'm sorry. Just a minute. Sorry. So it's not a single step process. We typically have, slide quality assessment. We've got tissue region selection. We've got, abnormality detection. We've got subtype narrowing, special stains as part of immunohistochemistry. We've got differential diagnosis generation. So each of these stages can be represented as independent agent operating in different artifacts. So these agents basically would generate whole slide scans. They would have embeddings, they would have annotations, and the resulting system would behave somewhat like a coordinated evidence processing pipeline rather than, let's say, a single inference model, right? Now, this would have certain infrastructure challenges like coordination, versioning, recoverability, etc. So conventional assumptions around static databases and linear workflows are increasingly difficult to maintain in such kind of environments. Now, sorry, just a minute. Let me present it again. Yeah, right. So now, one of the themes that from this ecosystem that we've mapped is the resilience as a protocol, as Manushil sir very kindly shared with us. So for us, workflow interruptions are not simply a compute failure. They might be evidence preservation. They might it'll affect reproducibility. It'll affect traceability. For example, if an agent falls midway through a pathology workflow, the system may need to determine which evidence object still exists, what kind of agents complete execution, what kind of outputs remain reproducible, whether the workflow can continue safely. So this kind of creates a requirement around distributed coordination. And we believe that a resilient pathology system should ideally understand what failed, what evidence survived, what must be recomputed. So for us, at the application layer, the pathology agents are responsible for analysis, detection, reporting, etc. Then we have IPLD, which become relevant for constructing linked evidence graphs between slide artifacts, patches, embeddings, as I previously mentioned. Then we have IPFS, which can provide content resilience and reproducibility. For us, LibP2P supports peer discovery, distributed communication. We've got multiple labs that are sort of trying to talk to each other. We've got a hub and spoke model where we have some of these centers existing in far parts, across the country. So you need task coordination among the labs, and so multi-formats improve obviously interoperability, which is a major concern in our field, and content references and portable proofs. So for us, since we have we're working with image scans on a level, it naturally pathology workflows naturally sort of produce artifacts with like different patterns, different locality requirements, different audit constraints. So this creates a very strong use case for composable infrastructure behavior. Our first primitive would be CID-based addressing. Each artifact, basically a slide scan or an annotation, receives a content identity. This would, let's say, enable deterministic referencing and like evidence traceability, which is very obvious. The second primitive is programmable retention, which is, for example, whole slide images may require like long-term archival needs. There may be temporary region crops, which may require short-lived retention. Diagnostic evidence may require compliance, grade persistence, things like that. So the third primitive for us would be incentivized pinning. Important evidence objects may need persistence across, like hospital nodes, research nodes, audit systems. And first, the fourth primitive would be agent local caching. This becomes useful because, as we have local embeddings and stain normalized, because, a lot of labs use different kinds of stains, different kind of IHC markers, which are basically what you stain your slides with. So keeping these objects close to the compute, improves retrieval latency and sort of the agent responsiveness. So the pathology workflow basically becomes a very strong example of content identity, locality retention. Last but not least, we feel that pathology becomes a good test bed for the resilient agentic infrastructure. Because we are essentially combining several difficult problems and properties simultaneously. We have massive artifacts in the form of our scans. We've got very sensitive medical data. We've got multiple interacting agents. We've got sparse critical agents. We've got human validation requirements, audit requirements. So we feel that it's kind of a useful environment to explore distributed coordination and composable persistence, recoverable workflows. So for us, a broader question is whether we can whether the surrounding ecosystem can preserve, coordinate, verify, and explain the evidence associated with, let's say, an output of a scan. So we are exploring computational pathology as a practical environment. The larger thesis is that high-stakes AI systems would increasingly require this infrastructure-aware intelligence, evidence-aware coordination, and survival operational architectures. And for us, Manushield sir has been a guiding light, and we would continue to explore LibP2P as and associated technologies in our workflow.
Thanks so much, Rajesh. Really appreciate that.